The goals of this module are to first introduce what a sanitation template is, second, to understand how to work with the sanitation template by following the flow paths of each product and then selecting each technology for each functional group, and finally, to be able to build a complete logical sanitation system. Let's actually do that now and select the technologies that we will need to form a complete sanitation system using this template as an example. Normally, we would know much more about the population, but in this case, we're going to have to make some assumptions. Let's assume that the population is made up of wipers and that they throw paper in the toilet, so we don't need a separate technology for it. Our gray cleansing material will follow this light line and mix it in with our urine, feces, and flush water. The urine, feces, and flush water, along with the toilet paper, will all flow into the user interface. And here we have two options. We can either choose a pour flush toilet or a cistern flush toilet. Let's, for the case of this example, choose a pour flush toilet. Here it is. We've marked it down so that we can build our system and continue from here. Once all of the products go into our pour flush toilet, they are mixed together and referred to as black water. The black water needs to be collected and stored. So here, it flows into the collection and storage functional group, and again we see we have three choices: a septic tank, an ABR, or an anaerobic filter. Let's say that we're designing for a small group of houses and there's a little bit of space, so we want to install something that's a little bit robust that can handle the variation of the black water inflow, and we decide on an anaerobic baffled reactor. Here it is. We've selected it for this technology interface. The ABR creates two different products, the effluent and the sludge, which settles to the bottom. The effluent, which is created constantly, needs to continually leave the system. In our example, let's say we have a bit of space, so we can pipe our effluent into a soak pit, shown here. The effluent will infiltrate through, and because we have some space, will be absorbed by the soil without any real impact on the surrounding area. So we've taken care of the effluent, we've followed it through. Now we need to deal with the sludge. The sludge that accumulates into the ABR will need to be emptied periodically. So let's assume that we are working in an area that has emptying businesses that own and operate pump trucks to suck out and transport the accumulated sludge. Here's our truck. It's come along and it's emptying this layer of sludge from our ABR. The truck will now need to transport it. We're lucky in this case because there is a functioning treatment plant dedicated for the sludge. It happens to be based on a planted drying bed. Here we can see the planted drying bed with the truck emptying the sludge into the grit chamber. The sludge will be layered on top of the filter. The effluent will filter through the porous layers beneath and will come out on this side. The sludge, as it accumulates, will dry and be turned into a dry sludge product. This dry sludge that comes off will need to be taken care of in some way. So what we're actually going to do is just give it away to some of the local farmers so that they can use it as a soil amender and help to improve the porosity and water storing properties of the soil. Remember, however, the planted drying bed produces two products, that dried sludge, which we've given away, but also the effluent, which comes out here and which needs further treatment. What we're going to do is dump it into one of the small local waste stabilization ponds that happens to be nearby. Quite lucky for us, but also a very useful technology. So the effluent from the planted drying bed that we have here will flow into our waste stabilization pond. Now, as a final step, we need to get rid of all of this effluent somehow. So what we're going to do is we're going to actually put fish into a final finishing pond and dilute that effluent so that we can grow fish and hopefully generate some revenue in the process. Of course, we could have chosen different technologies at each step for every product, so this is just one of many possible combinations. But still, you can see how we linked all of the technologies for each of the products all the way through to the very end. Furthermore, this is just one template. The choices we had were limited because of the type of input products and the logical sequence of technologies that were specific to this template. In summary, the system template is like a matrix of products and functional groups. Technologies are selected by following flow paths that guide each product through the necessary functional groups. There are a variety of technologies that can be chosen, so the ultimate decision is based on the context, the designer, and the end-use objectives.